Okay, so this is for section 6.4, and we're going to spend a good share of this week on this section on nth roots. You have worked with square roots and probably a little bit with cube roots. Okay, now we're going to look at any root. Okay, first, raising a number to the nth power and finding the nth root of a number or inverses of each other. Okay, most of you have done like taking things to the square power, to the cube power, to the fourth power. Well, now we're going to work with taking those roots. Like if I said 4 squared, okay, 4 squared is 16, and if I say the square root of 16, taking you back to 4, those are inverses of each other. One thing you do need to know, some terminology. If I said the cube root of 64, this little number is called the index. The number underneath the radical is called the radicand. And then this is just called the radical sign. Okay. The author also talks about the principal nth root. The principal nth root, and that's when there is more than one real root. The non-negative root is the principal nth root. And a lot of times, depending on your math book and your math author, a lot of times if I just said square root of 16, they will consider that to be 4. If I said plus or minus radical 16, if they put that symbol in front, then they'll say plus or minus 4. They consider both. Okay. Then a lot of times if they put x squared equals 16 and say solve that, if it put a variable in there and you take the square root of both sides, then they're considering positive or negative 4. But this would be like the principal nth root would be the non-negative one. Okay. I'm going to take you through some problems on simplifying roots, and for a while I am going to say probably you'll want to write these out this long way, and then once you get comfortable with it, then you can go to the shorter method. So let's look at some examples, and then we'll just say simplify. Say they had positive or negative square root of 16x to the 8th. To simplify that by working it the long way, what I mean is if I would break that x to the 8th up, and I look at whatever this index is. If that index is a square, then I'm going to break that x to the 8th up into x squared times x squared times x squared, and one more x squared. Remember, when you multiply monomials, you add the exponents. And then I would say out of this I could take out and it would be positive or negative because of this sign, positive or negative 4. Out of this I could take out an x, an x, an x, and an x, so out of that I could take out x to the 4th. Okay, so your final answer plus or minus 4x to the 4th. Try another one. So say I have the 4th root. Say I have the 4th root of 16 y to the 12th z to the 10th. Now it's different than square root or cube root. It's a 4th root. So I'm looking at the 4th root and 16. 4th root of 16 is actually 2. Because I can write 2 to the 4th. 2 times 2 would be 4 times 2 be 8 times 2 would be 16. So I can write that 16 as 2 to the 4th. I'm looking at powers of 4 underneath the radical. So the y to the 12th, or y to the 12th, I'm going to write that as y to the 4th times y to the 4th. That's y to the 8th times y to the 4th. Gives me y to the 12th. Z to the 10th would be z to the 4th. Z to the 4th, that'd give me z to the 8th, and I still have z to the 2nd. And that extend that radical out. Now under each one of those, out of this I could take out a 2. Out of this I could take out y to the 1st, y to the 2nd, y to the 3rd. So take out a y to the 3rd. Out of this I would take out z, and z would be z to the 2nd, and left inside I still have, if you circle it, then what's not circled is left inside, z to the 2nd. So 2y to the cube, z to the 2nd. And the most common error is people leave off the 4th root. They write it as a square root. Yep, that is the most common error. Okay. Because it's the 4th root of y to the 4th. Okay, it's just like if I said, what's the square root of y squared? You just take out a y. Cube root of y to the 3rd would just be y. Yeah. Makes sense? Okay. Okay, so this one is a 5th root. The index is a 5. 243. A to the 10th. B to the 15th. And if you take 243, now here's where you, on your calculator, you can take 243, the 5th root of that, on your calculator. If you go to the math key, okay, on the math key, number 5, okay, so we want the 5th root, so put in a 5, oops, put in a 5, and then really you need the math key, and then the number 5, and then 243. What that does is that when you write it like that on the calculator, it's going to go the xth root of 243. So it's going to put that 5 in for that x. Okay, so it's the 5th root of 243. You press enter. So 3, and you can check it. If you check on your calculator and do a check, 3 to the 5th power. You have to use that caret symbol. Do 3, and the caret symbol right above the division sign. 3 to the 5th power is 243. Okay, so we know that the 5th root, and I'm going to write it as 3 to the 5th power. Okay, and then a to the 10th, I want to split it up into powers of 5. Yeah, so I'd have a to the 5th times a to the 5th. Okay. B to the 5th times b to the 5th times b to the 5th. Okay, so out of this I can take out 3. I can take out A to the second, and B to the third. Okay? Starting to get the idea? Okay, but I really think that writing it this long way will help. And then when you get ready, you can, and you may not want to write it by the shortcut. Okay, now, if they take a square root of a negative, you got to remember to go back to the imaginaries. This is, split that up into -1 times 4. Out of this you can take out I, and out of this you can take out 2, so 2I. So you might get some imaginary numbers, okay, if you try to take the square root of a negative, okay. If they said to solve this over the set of real numbers, then your answer would be the empty set, okay. But if they say solve it over complex numbers, then your answer would be 2I, okay. Try another one. Positive or negative square root of 81 y to the 6th. Okay, you still keep that positive or negative. Don't drop that off. Okay, square root of 81 y to the 6th. We can split that up into y squared, y squared, y squared. So out of this you can take out 9. So we'd have positive or negative 9, and then y times y times y, y cubed, plus or minus 9y to the 3rd. Okay? Okay? So you have the 6th root. Okay, the 6th root of 729 x to the 30th y to the 18th. Okay, now let's try that on your calculator. Do 6 and then the math key, and then number 5, and then 729. So that is also 3. So we could write that as the 6th root of 3 to the 6th, and then the 30th we can go y to the, no, sorry, x. Yeah. There's 20, 25. Oh, sorry. That's my fault. Sorry. Go the other way. 6, 6, 6, 6. One more. Is that it? And then y to the 6th, y to the 6th, y to the 6th. Okay, so out of this we can take out 3, and then x, 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 x to the 5th, and y to the 3rd. Good? Okay. Okay, then they will throw in a polynomial. So you have the 5th root of the quantity x plus 2. That quantity is to the 15th power. You're still saying the quantity to the 15th, so you could look at the 5th root x plus 2 to the 5th, x plus 2 to the 5th, x plus 2 to the 5th, x plus 2 to the 3rd. Okay? Does it help you writing it out the long way? Okay. 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 Then the 6th root of 64 y plus 1 to the 14th. Oh, wait a minute. Sorry, my fault. That's not a 6. It's just a square. Square root of 64 y plus 1 to the 14th. Square root of 64? 8. Can you do the other one without writing it out? Y plus 1 to the 7. Okay? Okay, so you kind of get the idea with those. Okay, then the next part, the author is going to have you use a calculator. Use a calculator. Round, and don't miss it because of the rounding. Round to the nearest 1,000. 3 decimal places, yep. Okay, the 4th root of 50. Okay, so on your calculator, first double check and make sure you're in floating mode. You want to make sure in your mode that you're seeing all the decimal places. So go float mode. Okay, then go back to the home screen. We want the 4th root, so put in 4, and then the math key, and then number 5, and then 50. So it looks like it shows up on mine. On your new ones, doesn't it put a little square in there, a rectangle? Yeah, yeah. So on the old ones, it's going to do this. On the new ones, it's going to actually put it in there, right? Okay, and then press enter. And now if you want it to the nearest, yep, 2.659. Okay, try the 5th root, the 5th root of 79. Had you done this before today? No. Okay, 5th root of 79. So 5, and then the math key, and then number 5, and then 79. And I get 2.396 if you round it. 2.396. Okay? Okay, now, everything up to that point did not include an absolute value symbol. This part you need to star. Star. Simplify. Using absolute value. Oops, absolute value. And you find an even root. So that'd be like a square root, 4th root, 6th root, 8th root. When you find an even root of an even power, and the result is an odd power, you must use absolute value of the result to ensure the answer is non-negative. When you find an even root of an even power and the result is an odd power, you have to use an absolute value around it to ensure the answer is non-negative. Example. A couple of examples. So you had the 4th root of y to the 4th. Even root, even power. Answer, y to the 1st, which is odd. Absolute value goes around it. Okay? Try another one. Yep. So if you had square root of 36y to the 6th. So that's a square root of a y to the 6th. Okay? Square root of 36 is 6. And then you'd have y to the 3rd. It's an even root of an even power. The answer is odd. Absolute value around the y to the 3rd. Not around the 6. Another example. 4th root of 16, the quantity x minus 3 to the 12th. 4th root of 16 is 2. 4th root of x minus 3 to the 12th, x minus 3 to the 3rd. It's an even root and even power. The answer is odd. Absolute value around it. Okay? Okay, now, go back up to the problems we just worked. Okay, and we've got to figure out where the absolute values go. Okay, number 1 was even, and an even answer. No. Okay, number 2, even. Which one's odd answer? Y to the 3rd. Okay, go back in your answer. Put an absolute value around that y to the 3rd. Okay, number 3 is an odd root. That didn't work. It's an even root and an even power. So look at number 5. Even root, even power. Absolute value around the y to the 3rd. So absolute value around the y to the 3rd. Y to the 6th on that one. Yep. So number 6. Even root, even powers. Both those are odd answers. Okay, absolute value around the x to the 5th and the y to the 3rd. Okay, are we good there? Number 7's odd. Number 8. Absolute value around the y to the 7th. And that should be it. Okay? So, when you see the absolute values, it's when it's an even root, an even power, and the answer is to an odd power. Then you put the absolute values around it. Okay? Okay. That should be enough to get you started.